Hello again. In this video, I will be discussing the significance of the Euler equations, the Navier-Stokes equations, and the Lorentz force law. The Euler equations first appeared in the 18th century. They describe inviscid fluid motion. They are written out here with the velocity being represented by u, pressure being represented by p, and gravitational field being represented by g. 1, 2, and 3 are the x, y, and z components of each of these respectively. Fluid density is represented by ρ. The upside-down delta is the gradient. The Navier-Stokes equations appeared in the mid-19th century. They describe general fluid motion. They are the same as the Euler equations but add the viscous term. Kinematic viscosity is represented by nu, and the upside-down delta squared is the Laplacian operator. The Lorentz force law appeared in the late 19th century. The Lorentz force is represented by F. Q represents the net electric charge, E represents the electric field, V represents the velocity, and B represents the magnetic field. Consider the fluid equations with no pressure or viscosity term. Write them out completely. Consider the vorticity. Vorticity is a measure of how much a fluid rotates. It is mathematically described by the cross product of the del operator and the velocity. It is shown here. Take the cross product of velocity and vorticity. We get the expression shown here. Next, consider the gradient of 1/2 the magnitude of the velocity squared. We get this expression. Consider the difference between the two expressions we just derived. We get the same expression as the expression on the left-hand side of the fluid equations with no pressure or viscosity term written out completely. Therefore, we can rewrite the fluid equations as shown here. Multiply through by the mass. We get a term on the left side that has the units of force. Call this the Euler-Navier-Stokes force. Here are the fluids equations and the equations for electromagnetism or the Lorentz force law. Analyze the fluids equations. We have the mass term, vorticity term, and the gravitational field or acceleration term. For the electromagnetism equations, we have the net electric charge term. One term is the electric field, or the electrical acceleration term, and we have the magnetic field, also known as the electrical vorticity term. The difference is that we use mass in one equation and the net electric charge in the other equation. The field is the gravitational field in one equation and the electric field in the other. And finally, the rotational term is the vorticity in one equation, and the electrical vorticity, also known as magnetic field, in the other equation. They have a similar structure. The rule of these equations is to describe the total force due to translational and rotational effects.